Hello, and welcome back to What Is. Ever looked up at the night sky, seen all those twinkling lights, and thought, man, that's a lot of space? Well, you're not wrong, and even crazier. That space isn't just sitting there. It's getting bigger. Like, really bigger. And the cosmic party pooper responsible. What is dark energy, and why is space expanding? For a long time, scientists thought the universe was like a giant cosmic sigh. After the Big Bang, everything hurled outwards, but gravity, that ever-present cosmic bully, would eventually start pulling everything back in for a big galactic hug. Think of it like throwing a ball up in the air. It goes up, sure, but eventually, gravity always wins. Right? Wrong. Oh, so gloriously, spectacularly wrong. In the late 1990s, a couple of teams of astronomers were doing something incredibly complex and frankly, quite nerdy. They were studying supernova, those massive stellar explosions that happen when a star dies. Now, these supernova are like cosmic lighthouses. They have a known brightness, which means we can figure out how far away they are by how dim they appear. And what they found was baffling. These distant supernova were dimmer than they should have been. This meant they were further away than anyone expected for the amount of time it took their light to reach us. It was like finding out that the ball you threw up hadn't just stopped going up, but it was somehow being shoved away from you, faster and faster. This observation was a game changer. It suggested that the expansion of the universe wasn't slowing down, as predicted by gravity. Instead, it was accelerating. And to accelerate something, you need acceleration. Or in this case, something that pushes instead of pulls. Enter dark energy. Now, before you imagine some shadowy force lurking in the cosmic corners, let's be clear. We don't really know what dark energy is. It's one of the biggest mysteries in physics. But we do know what it does. It's this invisible, pervasive something that fills up space and exerts a kind of negative pressure, pushing everything apart. Think of it like this. Imagine you have a loaf of raisin bread dough. As the dough rises, the raisins are carried further apart. Now, imagine the dough itself is made of something that actively wants to expand. And it's not just rising passively, but it's booming, pushing the raisins apart with increasing speed. That expanding dough, that's kind of what dark energy is doing to the universe. And the dark part, well, it's dark because it doesn't interact with light. We can't see it, we can't detect it directly with our telescopes, and it doesn't seem to clump together like normal matter. It's essentially invisible to us. So, why is space expanding? Because of dark energy. It's like the universe has a built-in cosmic expansion button that's been slowly getting pushed down over billions of years. Now, here are some of the leading theories, and trust me, they get wild. One idea is that dark energy is a property of space itself. Einstein's theory of general relativity actually allows for something called a cosmological constant, which can represent a constant energy density throughout space. If this is true, as the universe expands and more space is created, there's more of this space energy to push it further. It's like a self-sustaining expansion engine. The more space there is, the more dark energy there is, the more space expands. You get the picture. It can feel a bit like a cosmic feedback loop. Another idea is that dark energy is a dynamic field, sometimes called quintessence. This is more like a fluid that permeates space, and its energy density can change over time. This would allow for more complex behaviors, like periods of faster or slower expansion. It's like a moody cosmic syrup that sometimes decides to spread out really quickly. Then there are the really out there ideas. Some theories suggest that dark energy is a sign that our understanding of gravity is incomplete. Maybe at cosmic scales, gravity behaves differently, Or maybe there are other dimensions influencing our universe. It's like finding out the rules of basketball are slightly different when you're playing on the moon. The sheer scale of this is mind-boggling. Dark energy is estimated to make up about 68% of the total energy and mass content of the universe. That's right, the stuff we can see. Stars, planets, galaxies, your cat, that's only about 5%. And then there's dark matter, that other mysterious, invisible stuff that holds galaxies together, making up about 27%. So, the universe is mostly made of things we can't see or fully understand. Pretty humbling, isn't it? The implications are profound. If dark energy continues to dominate, the universe will keep expanding at an accelerating rate. Eventually, galaxies will be so far apart that they'll disappear from each other's view. The cosmic pizza will keep getting bigger, but the toppings will be spread so thin you won't be able to see your neighbor's pepperoni anymore. This leads to a concept called the Big Freeze or heat death of the universe, where everything cools down and becomes spread out to the point where no more work can be done. Not exactly a party, but hey, at least there's plenty of room. So, while we're still trying to get our heads around dark energy and the accelerating expansion of space, the universe continues its grand, mysterious dance. It's a powerful reminder that even with all our scientific advancements, there's still so much wonder and mystery out there, waiting to be discovered. And that's what dark energy is, and why space is expanding. If you enjoyed this cosmic journey and want to unravel more of the universe's secrets, be sure to hit that subscribe button and ring the notification bell so you don't miss our next episode. What do you think is the most mind-blowing thing about dark energy? Let us know in the comments below. Thanks for watching What is